So I'm going to change the example you gave me so I can give you one similar to your homework. So if we had, say, a fourth root and we had 16 y to the sixth minus the fourth root of, I'm just going to use the same tail end sort of. We need to express these in fourths. So we know we're going to break this up. So we know that this is equivalent to 2 times 2 times 2 times 2 times y times y times y times y times y times y minus the cube root of y. So this can be squished down again. This is, oh, that's 4. That's 4. That's 2 to the fourth. And this is y to the fourth times y squared. The rules of exponents allow me to do this because y to the sixth is equal to any combination of anything that adds up to 6. Etc. So minus the fourth root of y. And I'm going to change this problem so it makes it easier. I'm cheating. So now what we're going to do is we're going to get rid of, come on, pen. Do your thing. You're not doing your thing. Why are you not doing your thing? We're going to get rid of any fourth that's there. So this is the cubed root of 2 to the fourth is just, the fourth root of 2 to the fourth is just 2. And then the fourth root of y to the fourth is just y. But we cannot take a fourth root of y squared. And that's why I changed it. But we can't really do anything with that anyway, so I shouldn't have changed it. So this is in simplest terms because I can't subtract the y. Because if this was 2 to the fourth y squared minus like y to the fourth y squared, if that y wasn't there, then we could simplify it further. Oh, no. So let me try another example, maybe something a little easier. So we'll go back to cube root. So this is just y, because this is y times y times y. And this is going to be y squared. Why is it y squared? It's because if we have the cubed root of y to the sixth, we have y to the 2, y to the 2, y to the 2. Or, rules of exponents. So we can't simplify this one down any further either. Now, the homework problem you sent me, I'm not going to do that one out completely because you do need to know this for calculus. You have the cubed root of 9 y to the fourth minus the cubed root of y. You can't do anything to this term. This term can't go anywhere, but this term we can do stuff with. We can break this up. This is, that's not a cubed. This is 3 squared. There's nothing we can do here. But, so the 9's got to stay underneath. But this, y to the fourth, is y cubed times y. So the y cubed can come out. So this is y. I totally did your problem for you. Oops. So again, nothing we can do here. This is in simplest terms. These examples are trying to get you to remember rules of exponents. And another little hint that can help you is when you see a cubed root, so like, or a fourth root, or a square root. So if I had x, the square root of x, that could be rewritten as x to the 1/2. So everything that I've done here can be done out with rules of exponents. So if I take just this example right here, just this term, and I don't have any more room. This becomes 16 y to the 6th raised to the 1/4. So 16 to the 1/4 and y to the 6/4 because we multiply. We're raising everything in there. And then this can be manipulated further down because we know that 16 is 2 to the 4th to the 1/4, which actually just becomes 2 to the 4 over 4, or 2 to the 1st. And then y to the 6/4, we reduce that down, becomes y to the 4 over 4, or 1, times y to the 2 over 4, which is left over. I don't know why my pen is making 4s weird. I'm sorry. But that's 4s, I promise. So that's y times 1/2 y, or y to the 1/2. So it's y to the square root of y. Now this took it further down from this. I'm sure this is what your teacher wants. But I took it down a little further. I feel like I went way too in depth with this problem. Let me know if it helped.